Today in Algebra 2, we're going to be looking at the second day of section 2.1. We're still focusing on quadratic functions and equations, but here you can see the three things we'll be talking about are writing the equation of a parabola in vertex form given the vertex and another point. We'll be talking about how to convert from vertex form to standard form, and we'll learn how to write the equation of a transform function. As we get going in this section, we're going to start with a warm-up. So I want you to pause the video and try this, but you're going to, given this function, identify the vertex, axis of symmetry, the maximum, minimum, domain, range of the function. This is what you did yesterday, so pause the video and try it on your own and then check your answer. So hopefully you were able to see that the vertex of this would be 3, 4, because the x minus 3 shifts the graph 3 to the right, and the plus 4 shifts it 4 up. So I'd plot a point at 3 to the right and 4 up. Which means that the axis of symmetry is going to be x equals 3. Now we could go a step further and graph the whole function. We talked about how we could make an xy table. Since this point's at 3, I can plug in 2 and 1 for the next points over. If I plug in 2, I get 2 minus 1 is negative 1 squared is 1, so negative 2 plus 4 is 2. So there's a point at 2, 2, which also means there's a point at 4, 2, because they're symmetric. If I plug in 1, I do 1 minus 3 is negative 2 squared is 4 times negative 2 is negative 8 plus 4 is negative 4. So at 1, I'd have a point at negative 4, which means also at 5. So this is a picture of it if you want the visual, plus it's good practice graphing. And when I look at that, I can clearly see that there's a maximum point in this case because it is upside down. So the maximum is a y value of 4. Domains of all parabolas are negative infinity to infinity, and the range you have to be a little bit careful with. Remember, this one's upside down. We have to start from lowest to highest, so it goes down to negative infinity, and it comes up to that 4. It is a point on the graph, so in interval notation, you do need to include the bracket. Okay, so now that we've summarized yesterday, hopefully you did well on that. Now we're going to talk about the first of those things I wrote on the first slide. We are going to learn how to write an equation of a parabola given a vertex and a point. So get this question written down. It says, what is the equation of a quadratic function with vertex negative 2, 3, and a y-intercept of negative 1? Now we do want to make sure we can write that y-intercept as an ordered pair. Y-intercepts are when x is 0. So it's the same as if I would have said and another point of 0, negative 1, because we can actually do this with any points we want. Now, as soon as you're given the vertex, you're going to want to use vertex form. So you will always want to write that down. Vertex form is y equals a times x minus h squared plus k. So just in case you don't have that, make sure you have vertex form written in your notes so you know what your starting point is. Now, you can see on the right-hand side, I have this table. Here, while I do each step, I'm going to write down the step that I did. Now, the vertex represents h and k. So my first step to write an equation in vertex form is to substitute the coordinates of the vertex in for h and k. So substitute coordinates of vertex in for h and k. So I take my y equals a, then I have x minus, now my h is a negative 2 squared, and then plus my k is a 3. Okay, so it's just a substitution idea. Step 2 is going to be to substitute the value of x and y from the given point and solve for a. From the other point and solve for a. Okay, now you could eventually combine steps 1 and 2 together where you're substituting everything, but now I know this is my x and this is my y. So I'm going to put a negative 1 in for y. I don't know what a is. That's what I'm solving for. X is 0. Now in this step, I'm going to say I know a minus a negative is the same as plus 2. Now I'm going to simplify and solve. Negative 1 equals a 0 plus 2 is 2 squared plus 3. Usually you can do this in less steps, but I want to show you once. 2 squared is 4, so that's the same as 4 times a, because a times 4. Subtract 3, negative 4 equals 4a, and divide by 4. Again, usually I wouldn't show all of those steps, but I want to make sure the first time you see it that you see all of the algebra. Having said that, now that we know a, we are going to substitute a, h, and k back into vertex form. So what that means is I take this equation. My final answer is y equals, for the a, I'm going to substitute the negative 1 times, and then we already saw that we're going to have x plus 2 squared because we had the minus a negative 2, and then plus 3 on the end. So here's my equation in vertex form if I'm given a vertex of negative 2, 3 and a y-intercept or the point 0, negative 1. Okay. Once you have that, I want you to pause your video and I want you to try this. Okay, go through those 3 steps. This time the vertex has a vertex of, or the parabola has a vertex of 1, negative 4, and it passes through the point negative 2, negative 1. So pause the video, go through those 3 steps, and then unpause and see how you did. All right, so you can see I go through my 3 steps here. I write down vertex form first all the time just because I like to see it that way. Step 1, I substituted 1 for h, negative 4 for k. That was my vertex. Step 2, I then took my x and my y and substituted negative 1 for y, negative 4 for, negative 2 for x. And then I simplified, combined these. Negative 3 squared is positive 9, and then I added 4 and divided by 9. Now, I did end up with a fraction, and that's okay. You would typically want to leave it as a fraction, not turn it into a decimal. But now I take that a, h, and k and plug it back in, and you should have gotten 1/3 times x minus 1 squared minus 4. Now, one common mistake when we're writing in vertex form, please don't forget to put the squared here. I've seen a lot of students forget that over the years, and we want to be careful. Okay, let's take this and now extend it one more step. First, we're going to look at a word problem, but then we're also going to learn how to convert to standard form. One thing I want you to think about is sometimes word problems scare us away, but think about what they give you, because this is actually not much different than what we did in the last problem. It says the height of a thrown ball is a quadratic function of the time it has been in the air. The graph of the quadratic function is the parabolic path of the ball. The vertex of the graph is 120, and the path of the ball includes the point 0,4. What is an expression that defines this function? Write the quadratic equation in vertex form and in the form y equals ax squared plus bx plus c. Okay, so what we see here is that even though there's a lot of words and it's a real world situation, they gave me the vertex and another point. So to write it in vertex form, I do what we just did. Y equals a times x minus h squared plus k. Y equals a times x minus, my h is 1, my k is 20. That came from this vertex here. And then next I plug in 0 and 4 for my x and my y. Again, you can do those in the same step. Sometimes students just get confused if they're plugging too many things in at one time. So I get 4 equals a times 0 minus 1 squared plus 20. Now when I look at this, I have 0 minus 1, which is negative 1. Negative 1 squared is positive 1. So all of this actually just becomes 1, which means it doesn't matter. It's a 1a, but I don't need the 1. So I'll just subtract 20 from both sides. I get negative 16 equals a. So in this case, my vertex form would be y equals negative 16 times x minus 1 squared plus 20. Okay, so that's review of the previous side. Now, I want you to make sure that you get in your notes, standard form is the form y equals ax squared plus bx plus c. Okay, so you need to understand the difference between vertex form and standard form. And now we're going to talk about the 3 steps to take vertex form and convert it. So if I'm going to convert, I need to start with the first one. And then you're actually just doing order of operations. Order of operations starts with inside parentheses. I do have parentheses, but I can't simplify x minus 1. So step 2 is to look at the exponent. So I need to do x minus 1 squared. X minus 1 is called a binomial, and since we're squaring it, it's called a binomial squared. So when I write down my steps for converting, I write down step 1 is to expand the binomial squared. Now I do want you to make sure you understand that when we square something, it means we multiply it by itself. I wouldn't usually write this out, but this is the same as x minus 1 times x minus 1. The reason I show that is a lot of students make a mistake multiplying that together. Now you've learned over the years that if you have two binomials times each other, you can FOIL. So first times first, or outside times outside, inside times inside, and last times last. You should end up with 3 terms when you do that. Some books and strategies also use an area model to multiply two binomials together. You'd put your x and minus 1 outside both sides. Some people always think this looks like the lattice method. So x times x is x squared, x times negative 1 is negative 1x, x times negative 1 is negative 1x, and negative 1 times negative 1 is 1. So using the area model, you're finding the area of the 4 little squares, but then you add them together. Either way, whether you FOIL or you use the area model, you should end up with x squared, because now we combine like terms, minus 1x plus minus 1x is minus 2x, and then plus 1. A lot of students forget that middle term. They think it's just x squared plus 1. Make sure you expand it fully. Okay, now once I do this, again, going through my order of operations, multiplication and division come next. So we are going to distribute that negative 16. So step 2 is to distribute a to everything inside parentheses. Okay, so just to these 3 pieces. So I get negative 16x squared. Negative 16 times negative 2 is plus 32x, and then negative 16 times 1 is minus 16. Don't forget to bring down the plus 20, but you're not going to multiply by 16. And then finally, step 3 is to combine like terms, which in this case will always be the constants on the end. So my final standard form quadratic is negative 16x squared plus 32x, and when I add these together, I get plus 4. Remember, when we convert, that means it's a different way to represent the exact same thing. So this vertex form, negative 16 times x minus 1 squared plus 20, would actually give me the exact same graph as y equals negative 16x squared plus 32x plus 4. And both of these versions have their advantages and disadvantages, so that's why we need to learn both. Okay, I want you to try it. Here you are given a graph. And just a tip, the graph shows the height of the flying disk with respect to time. What is the equation of the function? Write the equation in vertex form, then write the equation in the form y equals ax squared plus bx plus c, or standard form. Pay attention on the graph. Think about what the point 210 is called, and this is just another point. So you should be able to do this following the same strategy we've been using. So pause the video, give it a try, and then play it to see how you did. Okay, so hopefully you were able to go through the process. In vertex form, remember this one's vertex form, you should have ended up with negative 3/2 times x minus 2 squared plus 10. You did end up with that ugly fraction in front, but it'll be just fine. If you didn't get it, please look back at my work to see where you went wrong. Now, obviously, if you got that wrong, your next answer is also going to be wrong. But for your standard form, you should have had y equals negative 3/2 x squared plus 6x plus 4. Okay, so once again, we expand the binomial first. I showed that work in my box over here. Should have gotten x squared minus 4x plus 4. If you were missing the 4x, that's the common, or the minus 4x, that's the common mistake. When we distribute the fraction, that might have been another place you had problems. The negative 3/2 x squared is pretty straightforward, but negative 3/2 times negative 4, remember when we multiply fractions, you can multiply top times top. So that would be 3 times 4 is positive 12 over 2, which is 6. Another strategy with that, negative 3/2 times negative 4, you can cancel this 2 with the 4. Okay, because it's multiplication, you can actually cancel across. So that also would give you positive 6. Okay, and then finally the negative 3/2 times positive 4 would be negative 6 plus 10, and that's how the negative 6 plus 10 gives me plus 4 on the end. All right, last but not least, we want to be able to write an equation of a transform function. And hopefully if you've understood this in the last chapter as well as yesterday's lesson, this is just extending it one step further. So it says the function g is a translation of the parent function f, but it's 1 unit to the left and 3 units up. What is the equation of g? And it's telling me it's quadratic. So what that means is I need to take g of x. F of x would be, because it's quadratic, the parent function is x squared. So they're asking me to write an equation that's shifted 1 left. Well, in order to shift things left and right, I remember that it must be grouped with the x. And it's the opposite of what I would think. So if I want to go 1 left, I'm actually going to write x plus 1. Don't forget the square. Again, that's a common mistake. And then finally, if I want to translate it 3 units up, that's when I add and subtract things, but not grouped with the x. So in order to move it 3 up, I would do a plus 3, because when it's a vertical shift, it's as you would think. Okay, so that's actually vertex form. I'm done with that part. Now it does also want me to now practice converting. Okay, since there's no a value, it actually saves me a step. I would do the x plus 1 times x plus 1. This time I'm going to show it with foiling. So I would have x times x is x squared. 1x times x is plus 1x, plus 1x, plus 1. Again, we had this on the previous example, the x plus 1 squared, but I wanted to show the other way to do it. X squared, there's plus 2x's, and then plus 4. Since it does not have an a value, I can just move ahead without it. Remember, if there was an a there, I would have to keep this part in parentheses. All right. Last but not least, I want you to pause the video. This gives you 2 opportunities to try this again. If you're unsure, I will walk through the first one a little bit quicker, or a little bit more in depth, so you can stay on and watch me do part A and pause for part B. If you're feeling really good about it, you can pause right now and try both of these. Okay, so for part A, it's asking me to do what we just did. I'm going to write j as a quadratic function whose graph is translated 2 units right and 5 down. So again, I keep my a the same. 2 to the right would be x minus 2 squared, because it's the opposite what I think. 5 down would be a minus 5 on the end. Okay, so that's my vertex form. It wants me to then also convert it. So 2 parts for each problem. If I'm going to convert this, again, I would do x minus 2 times x minus 2. As you keep practicing, you may not need to write that out. I know it's x squared minus 2x gives me minus 4x, and then a negative 2 times a negative 2 is plus 4. Again, because there's no number here, I do not need to put it in parentheses. If it had a different a value than 1, I would need to keep that in parentheses. But now my standard form is x squared minus 4x minus 1. Okay, so if you needed to see another example and you watch me walk through that, you can now pause it because I want to make sure you try B on your own. Okay, and last but not least, here you go. The last one was a little unique. It was a reflection over the x-axis. And remember, the x-axis is this one, which means that it would, to reflect it vertically, that would be over the x-axis. So that's why I put the negative outside of the parentheses. I decided to leave it in, so then it has a vertex. It does not shift left or right, so that's why it's 0 here, but the 1 down would be a minus 1 on the outside. So I just left vertex form like that, and then x minus 0 times x minus 0 is just x squared times a negative 1, and then a negative 1 on the end. So it is just negative x squared minus 1. So that one might have been a little tricky because it didn't have as much information, which sometimes actually makes it a little harder. But just a reminder that that negative in front of parentheses or outside of the grouping with the x will reflect it over the x-axis. Okay, if you want to see a summary of kind of what we've talked about, you can pause and read through this. But otherwise, you can head over to Pearson and start working on your Section 2.1 Day 2 assignment.